Assalamualaikum and hi everyone. My name is Raja Anis and today I will be presenting my final year project titled Synthesis, Characterization, Anti-bacterial Studies of Isatin Derivatives and its copper and cobalt complex. This project was conducted under the supervision of Dr. Karima. So here are the outline of my presentation today. Okay, let's move to the introduction. First, for the research background. Sheaf-based are compound formed through condensation between a primary amine and a carbonic compound producing imine group which is C double bond N. Isatin, which is my starting compound, has strong antimicrobial, antiviral, and also anti-cancer. When sheaf-based are coordinated with metal ion like copper and cobalt, their biological activity is often enhanced. Also, this complex may act by disrupting microbial enzymes and increase the antibacterial activity. Next, for the problem statement, the effectiveness of antibiotic has decreased due to bacterial resistance. Also, there are limited studies that conduct on acetin sheaf base and its metal complex, especially in copper and cobalt. Next, for the significance of study. This study is significant because it explores new metal ligand complex with potential antibacterial application and contribute to the field of medicinal inorganic chemistry. Okay, next, there are three main objectives for this project, which is first is to synthesize sugars from acetin and two different amines. Next is to characterize the ligand and their copper and cobalt complex using physical analysis, CHNS, FTIR, UV-based and also NMR spectroscopy. Lastly is to evaluate the antibacterial activity of the ligands and complex using the disk diffusion method. Okay, next we move to the literature review. Previous studies have shown that sheaf-based and their metal complex have the strong biological properties compared to the free ligand. Also, many previous studies like 10 years before used the same method like reflux method to synthesize this sheaf-based. But in this project, I only change for the chemical and the solvent. After all the compound has been synthesized, it will undergo characterization using variable chemical analysis such as physical analysis, CHNS, FTIR, UV-based and NMR spectroscopy. Okay, for methodology, as you can see, ligand 1 was synthesized by reacting acetate with 2-phenylethanol 1-amine under reflux method for 3 hours in the ethanol. Then the product will be filtered, washed with cool ethanol and dried for 1 day. After that, it will undergo the characterization. Ligand 2 was synthesized from acetin and O-phenylene diamine and is also used the same method with the ligand. Then, each ligand was then reacted with copper and cobalt to form their respective metal complex. And they are also used the same method with the ligand. Next, results and discussion. For the physical analysis, distinct color change will observed after the complexation. For example, as you can see, ligand 1 is yellow, copper ligand 1 turns orange-brown, and cobalt ligand 1 appears dark brown. This confirms the coordination between the ligand and the metal ions. The metal complex also had a higher metal points than the ligand, suggesting greater thermostability due to stronger metal ligand bonds. Also, copper ligand 2 showing the highest yield, likely due to the better reactivity of the diamine ligand. Okay, next for the CHNS elemental analysis. The elemental percentage of carbon, hydrogen, nitrogen were all close to the theoretical values. This confirmed the expected molecular structure and purity of the synthesis ligand and the metal complex. However, it also has slight deviation due to incomplete drying. The sulfur content was 0%, which aligns with the fact that no sulfur is present in any of the compounds. Okay, next in the FTIR spectrum, the C double bond N stretch for ligands appear around 1616 cm. This band shifted to lower values in the metal complex, indicating coordination through the azimuthine nitrogen. New bands also appear in the 500 to 750 cm range, corresponding to metal nitrogen and metal oxygen vibration, further confirming successful complex formation. Next, for UVVs, the free ligands, bands appear from around 230 to 330 nanometer, corresponding to pi to pi star and n to pi star transition from the aromatic rings and the long pairs. In the metal complex, as you can see, new absorption bands appear between 330 to 400 nanometer, indicating legal to metal charge transfer, which is LMCT. This shift, especially the bathochromatic shift, support the metal-ligand coordination. Last but not least, for the NMR spectroscopy. The NMR spectrum for ligand 1 shows a singlet at 7.6 ppm for the azimuthal proton, indicating successful chain-based formation. Also, a singlet at 9.6 ppm corresponds to the enhanced proton from the Isatin moiety. Also, multiplets between 3.27 to 4.28 ppm represent the CH2 protons near the nitrogen and phenyl ring. These signals match the proposed structure. But NMR was not conducted for the metal complex due to their parametric nature, which can interfere with the spectrum. Okay, next, for the conclusion, shift-based ligand was successfully synthesized from Isatin and two different amines with copper and cobalt. The shift-based ligand and the complex were formed and confirmed using various characterization techniques. The FTIR and UV-based data supported the metal coordination, the NMR supported the molecular structure, and the CHNS analysis confirmed the elemental composition. But sadly, the antibacterial test was not fully completed due to time limitation. But it's okay, it will be continued for the next study. So, for the recommendation for future study, I will recommend to explore the additional metal ions such as zinc or ferrum. Next is to improving the synthesis method like reflux for a longer time to produce high percentage yield. Next is using the green chemistry method like ethanol-based or eco-friendly solvent. And lastly is to run the antibacterial and molecular docking studies to explore biological mechanism. So here are the main references that I use to support my project and my thesis. Okay, this is my acknowledgements. First and foremost, I would like to sincerely thank to my supervisor, Dr. Karima, and also my family and friends for their support throughout this project. Thank you so much. So, that's all from me. Thank you for listening and watching. Bye.